Do you have any sense of timelines? I mean, we are mortal beings.
Yep.
And I'm used to the thought that these changes are, occur over millions of years, not a couple of years.
Okay, let me give you some specific data that's not in the paper, because if I put everything we know in the paper, it would have been a book.
Sure.
In fact, it will be a book. This is going to be a good chunk of the next book, the sequel to The Monuments of Mars I'm trying to write in my Sophie's spare time, with a lot more reference, a lot more data. For the last 10 years or so, there have been two major drilling projects going on, both in the northern climates, northern polar regions in the Greenland ice cap, and down at the South Pole. We have been doing drilling, and the Russians have been doing drilling. And they've gone down deep enough, a mile or two, to where they've got about 200,000 years of data.
They pull up core samples?
They pull up cores of ice, and the theory here is that it snows, and then it compacts. And it snows, and it compacts. And so snow eventually turns to ice.
Right.
It eventually turns to very hard ice. And down near the bottom, if you pick the right place to drill, that ice has not been disturbed. It hasn't moved, certainly hasn't melted, in hundreds of thousands or maybe a million years. That's some of the current models, all right?
Okay.
In the ice, there are little bubbles of air trapped. And in those little bubbles of air, they can sample when they bring up the cores and slice them and put them in these cold sheds and tag them and catalog them and all that. They can thin section, meaning they take a little saw and they saw these long cores into fine slices. And then they can basically measure how deep that slice came from, which, based on certain assumptions about snowfall and compaction and all that, it translates to the number of years since that snow saw the light of day. And so then they sample the little air bubbles in that ice at that depth, and that tells them what the atmosphere was doing and the temperature and the climate, etc., at that incredibly distant point far back in time, going back like 200,000 years. And what they found in trying to figure out ice ages, for instance, is that in as short as a year or 5 years, you can go from warm, almost tropical climate to glacial overnight, just like you turn off a light switch. And then it reverts suddenly, just as suddenly. And this, when they found this a couple of years ago, the data was so unbelievable that, of course, nobody believed them. Now they have from both poles enough data to show that not only does this occur, but we can go from very warm to very cold, just like you turn off a light switch, and back again. But unlike all the glacial models that have been proposed for driving glacial cycles, the Milankovitch cycle is the most predominant one that is tagged to the Earth's orbit and the way it changes ellipticity and the axis of the Earth wiggles back and forth and all that.
Right.
Which predicts that you'd have glaciation in one hemisphere. What they're seeing in this core data from both poles is it's occurring simultaneously in both hemispheres, which none of their models can allow for. The hyperdimensional model easily accounts for that, both in terms of both poles simultaneously and the short time span. Because what the hyperdimensional model is basically saying is that the environment of this planet, of the entire solar system, is basically determined by the changing positions of the planets we know, predominantly Jupiter and Saturn, and now by probably a couple of guys far out there that we don't know yet, that have not been found yet, which move very slowly. And because the farther you are from the sun, the slower a planet moves. Mercury goes around in 88 days. Pluto takes 250 years. The planets I'm talking about, they go around in periods as long as 2,000 years or even 26,000 years for the last one that I'm thinking might be out there. The phase relationships, the time it takes for them to change angle with each other,
yes,
to hit certain of these so-called tetrahedral hyperdimensional angles, like 120 degrees, 60 degrees, 90 degrees, is very, very long time scales. So those would drive the huge cycles. And the inner guys, and I include Saturn and Jupiter as the inner guys, drive much shorter cycles. So you can think of it as if you kind of imagine a big bank of heaters, all right, and somebody's standing by a set of rheostats,
Right.
and they're turning the rheostats. And one guy is turning them on a time scale of several days, up and down, up and down. And another guy at the other end of the hall, this huge power plant, let's say, is turning his dial every few minutes, back and forth, back and forth, back and forth. So the big cycles are driven by the outer guys, and then those are modulated by the much more rapid rotation around the sun of the inner guys. So you have cycles on cycles on cycles. And those cycles basically are changing the properties of space-time itself in this model.
Is there any way through this model for you to tell me in the near term what we have to look forward to?
More change. In other words, the long-term trend is you're going to have more available energy, if we're correct. And on that more energy, which has to go somewhere, the phasings of the inner guys, Jupiter, Saturn primarily, will result in shorter-term changes, and the inner guys, Mercury and Venus and Mars, determine even shorter cycles. So you'll have very rapid switches because there's a lot more energy running around in the system, and this energy doesn't just drive weather or the geology, earthquakes and volcanoes. It drives everything.
Yeah, well, the importance of this to us is we actually exist and live in an environment that operates, at least for the human being, on a kind of a thin line. I mean, you can't take very many degrees of change either up or down and expect us to grow crops where we have been growing them, to have large human populations in the coastal areas where they have been, et cetera, et cetera, et cetera. So a very small change can produce a very, very big effect. Are we about to have a very big effect? Or more accurately, are we having it?
We're having it, Art. And unless we get our facts straight and our model straight and our physics straight, there's not a damn thing we're going to be able to do about it. Remember, the first step in affecting your environment is understanding your environment. If you think it's because you're dumping fossil fuels in the atmosphere and you produce a whole bunch of laws to stop that, and it ain't that at all.
And it doesn't work.
It doesn't work.
Yeah, I have no idea why it's happening. I just observe it is happening.
It is happening, and it's happening on a very short time frame, and that's the key
I can
signature.
see that. I can see that, a very short time frame. In other words, if you can project, and I can in my own mind, that we get as much change in the next 2 years, say, as we have had in the last 2 years, we're going to be in a pretty precarious position.
In the normal course of events, over the recorded history which we've known, all right, the sun has been very constant. In fact, back in the early parts of this century when the Smithsonian was actually measuring...
Hey, Richard, can you hold for a second?
Absolutely.
I'm right up against the time deadline. Stand by. We'll be right back.
Often imitated, never duplicated. This is News Talk 89 WLS.